When dealing with a cable run from a communication room to a tabletop box, and instead of running one direct one from the patch panel to the device, you introduce a consolidation point or patch panel near the device, followed by a patch cord to the device. The responsibility for testing encompasses both segments of the cabling infrastructure. This means that you are responsible for testing not only the permanent link, which is the cable run from the patch panel in the communication room to the consolidation point near the device, but also the patch cord that connects the consolidation point to the device. While patch cords are often prefabricated and may come with a manufacturer's certification of compliance, relying solely on this pre-certification is not sufficient to guarantee proper functionality in the field. There are several reasons why field testing of patch cords is necessary, even if they are pre-certified. Firstly, damage can occur during shipping, handling, or installation. Patch cords can be subjected to various forms of stress and physical impact, which can compromise their integrity and performance. A visual inspection may not always reveal subtle damage that can affect signal transmission. Secondly, patch cords may not be fully compatible with the consolidation point or the device to which they are connected. Even if the patch cord meets the general specifications for the cabling system, there may be subtle differences in connectors, wiring configurations, or other parameters that can lead to performance issues or even damage to the equipment. Thirdly, the installation environment can introduce factors that affect the performance of patch cords. Electromagnetic interference, temperature variations, and humidity can all impact signal transmission and degrade the performance of the cabling system. Field testing allows you to assess the impact of these environmental factors and ensure that the patch cord is performing as expected. By testing both the cable run and the patch cord, you can ensure that the entire link between the communication room and the device is functioning properly and meets the required performance specifications. This comprehensive testing approach provides several benefits, including firstly, ensuring reliable network performance. By verifying that both the cable run and the patch cord meet the required performance specifications, you can minimize the risk of network outages, slow data transfer speeds, and other performance issues. Secondly, preventing equipment damage. Faulty patch cords or compatibility issues can lead to damage to the connected devices. Testing helps to identify and resolve these issues before they cause costly damage. Thirdly, complying with industry standards. Many industry standards and regulations require comprehensive testing of cabling systems to ensure compliance and safety. Testing both the cable run and the patch cord helps to meet these requirements. Fourthly, simplifying troubleshooting. When troubleshooting network issues, having tested both the cable run and the patch cord eliminates these components as potential sources of the problem, allowing you to focus on other areas of the network. The testing process for both the cable run and the patch cord involves using specialized testing equipment to verify various parameters such as wire map, length, insertion loss, return loss, near-end crosstalk, and alien crosstalk. These tests help to identify any defects or performance issues that may affect the overall performance of the cabling system. For the cable run from the patch panel to the consolidation point, the testing process typically involves using a cable analyzer to perform a series of tests that verify the integrity of the cable and its connectors. The cable analyzer will generate a test report that shows the results of each test, indicating whether the cable meets the required performance specifications. For the patch cord, the testing process may involve using a patch cord tester or a cable analyzer with patch cord testing capabilities. These testers can verify the wire map, length, and performance characteristics of the patch cord, ensuring that it meets the required specifications. In addition to testing the electrical characteristics of the cable run and patch cord, it is also important to visually inspect them for any signs of damage or defects. Check the cable jacket for cuts, abrasions, or other damage that could compromise its integrity. Inspect the connectors for bent or broken pins, loose connections, or other signs of wear and tear. If any damage or defects are found, the cable or patch cord should be replaced immediately. When selecting patch cords for use in a cabling system, it is important to choose high-quality patch cords that meet the required performance specifications. Look for patch cords that are certified by a reputable testing laboratory and that are made from high-quality materials. Ensure that the patch cords are the correct length and that they have the appropriate connectors for the equipment to which they will be connected. In summary, when using a consolidation point and a patch cord to connect a device to a patch panel, you are responsible for testing both the cable run from the patch panel to the consolidation point and the patch cord from the consolidation point to the device. This comprehensive testing approach ensures that the entire link between the communication room and the device is functioning properly and meets the required performance specifications, preventing performance issues, equipment damage, and compliance violations. Remember to always use appropriate testing equipment, follow industry best practices, and visually inspect the cables and connectors for any signs of damage or defects. By taking these precautions, you can ensure the reliability and performance of your cabling system. When performing cable testing, several key parameters are assessed to ensure the cable meets the required standards for data transmission. These parameters include wire map length, insertion loss, return loss, near-end crosstalk, and alien crosstalk. Firstly, wire map refers to the proper connection of each wire within the cable to the corresponding pin on the connector. A wire map test verifies that each wire is connected correctly and that there are no opens, shorts, or reverse pairs. Incorrect wiring can lead to data transmission errors and network performance issues. Secondly, length measures the physical length of the cable. It is important to ensure that the cable length does not exceed the maximum specified length for the cabling system. Exceeding the maximum cable length can result in signal degradation and reduced network performance. Thirdly, insertion loss, also known as attenuation, measures the amount of signal loss that occurs as the signal travels through the cable. Insertion loss is typically expressed in decibels and is frequency dependent, meaning that it increases with frequency. Excessive insertion loss can weaken the signal and reduce the distance over which data can be transmitted reliably. Fourthly, return loss measures the amount of signal that is reflected back towards the transmitter due to impedance mismatches in the cable or connectors. High return loss can indicate problems with the cable or connectors and can lead to signal distortion and data transmission errors. Fifthly, near-end crosstalk, or NEXT, measures the amount of signal coupling from one wire pair to another within the cable at the near end, meaning the end where the signal originates. Excessive NEXT can interfere with the desired signal and cause data transmission errors. Sixthly, alien crosstalk, or AXT, measures the amount of signal coupling from one cable to another cable in close proximity. Alien crosstalk can be a significant issue in high-density cabling environments where multiple cables are bundled together. Excessive AXT can interfere with data transmission and reduce network performance. To perform these tests, specialized testing equipment such as cable analyzers and patch cord testers are used. These testers generate test signals and measure the response of the cable to those signals, providing detailed information about the cable's performance characteristics. The test results are then compared to the applicable industry standards to determine whether the cable meets the required specifications. In addition to these key parameters, other tests may be performed to assess the cable's performance under various conditions. For example, resistance imbalance testing measures the difference in resistance between the wires in a pair, which can affect power over Ethernet performance. Transverse conversion loss testing measures the cable's ability to reject common mode noise, which can improve signal integrity. Shielding effectiveness testing measures the cable's ability to block electromagnetic interference, which can protect the signal from external noise sources. By performing a comprehensive set of tests and verifying that the cable meets the required specifications, you can ensure that the cabling system is capable of supporting the intended data transmission rates and applications. This can help to prevent network outages, performance issues, and other problems that can disrupt business operations. In addition to testing the electrical characteristics of the cable, it is also important to visually inspect the cable and connectors for any signs of damage or defects. Check the cable jacket for cuts, abrasions, or other damage that could compromise its integrity. Inspect the connectors for bent or broken pins, loose connections, or other signs of wear and tear. If any damage or defects are found, the cable should be replaced immediately. When selecting cables and connectors for use in a cabling system, it is important to choose high-quality components that meet the required performance specifications. Look for cables and connectors that are certified by a reputable testing laboratory and that are made from high-quality materials. Ensure that the cables are the correct length and that they have the appropriate connectors for the equipment to which they will be connected. By taking these precautions, you can ensure the reliability and performance of your cabling system and minimize the risk of network problems. The importance of adhering to industry standards when testing cabling systems cannot be overstated. Industry standards provide a common framework for designing, installing, and testing cabling systems, ensuring that they meet the required performance specifications and are compatible with other network equipment. These standards are developed by organizations such as the Telecommunications Industry Association, or TIRE, and the International Organization for Standardization, or ISA, and are based on extensive research and testing. Adhering to industry standards helps to ensure that cabling systems are installed correctly, perform reliably, and support the intended data transmission rates and applications. It also simplifies troubleshooting and maintenance, as technicians can rely on a common set of standards and practices. There are several key industry standards that are relevant to cabling system testing. Firstly, TIA 568.0D is the main standard for commercial building telecommunications cabling. It specifies the requirements for cabling system design, installation, and testing, including the types of cables, connectors, and topologies that can be used. Secondly, ISO, or International Electrotechnical Commission, IEC 11801 is an international standard for generic cabling systems. It is similar to TIA 568.0D but is used in many countries outside of North America. Thirdly, TIA 1152 specifies the field testing requirements for balanced twisted pair cabling. It defines the test procedures, test equipment, and performance requirements for various cabling categories such as Category 5E, Category 6, and Category 6A. Fourthly, ISO or IEC 61935-1 specifies the requirements for testing installed cabling. It covers the same topics as TIA 1152 but is used in many countries outside of North America. These standards specify the test parameters that must be measured, the test procedures that must be followed, and the performance requirements that must be met. They also provide guidance on how to interpret the test results and troubleshoot any problems that are identified. When performing cable testing, it is important to use test equipment that meets the requirements of the applicable industry standards. Cable analyzers and patch cord testers should be calibrated regularly to ensure that they are providing accurate and reliable results. Technicians should be trained on the proper use of the test equipment and should be familiar with the industry standards that are being used. In addition to adhering to industry standards, it is also important to follow best practices for cable installation and termination. Cables should be properly supported and protected from physical damage. Connectors should be terminated carefully and securely to ensure that they provide a reliable connection. Cables should be labeled clearly and accurately to facilitate troubleshooting and maintenance. By following these best practices, you can ensure that the cabling system is installed correctly, performs reliably, and meets the required performance specifications. This can help to prevent network outages, performance issues, and other problems that can disrupt business operations. Furthermore, it's crucial to understand the difference between component testing and field testing. Component testing refers to testing individual components of the cabling system, such as cables, connectors, and patch cords, in a laboratory environment. This type of testing is typically performed by manufacturers to ensure that their products meet the required performance specifications. Field testing, on the other hand, refers to testing the installed cabling system in its actual operating environment. This type of testing is performed by installers and technicians to ensure that the cabling system is installed correctly and performs reliably. Component testing is important for ensuring that the individual components of the cabling system are of high quality. However, it does not guarantee that the installed cabling system will perform as expected. Field testing is necessary to verify that the installed cabling system meets the required performance specifications and is capable of supporting the intended data transmission rates and applications. When performing field testing, it is important to use test equipment that is designed for field testing applications. Field testers are typically more rugged and portable than laboratory testers and are designed to withstand the rigors of the field environment. They also typically have features that are specifically designed for field testing, such as the ability to store test results and generate test reports. It's also worth noting that certification programs exist for cabling systems. These programs are offered by various organizations and provide assurance that the cabling system has been designed, installed, and tested in accordance with industry standards. Certification programs typically involve a combination of component testing, field testing, and documentation review. Obtaining certification for a cabling system can provide added confidence that the system will perform reliably and meet the required performance specifications. In conclusion, understanding the nuances of cable testing, including the parameters tested, adherence to industry standards, the difference between component and field testing, and the availability of certification programs, is crucial for ensuring the reliability and performance of cabling systems. By following best practices for cable installation and termination, and by using appropriate test equipment and procedures, you can minimize the risk of network outages, performance issues, and other problems that can disrupt business operations. Remember to always prioritize comprehensive testing to ensure robust and reliable network infrastructure.